Welcome back. In this lecture, we are going to understand about a creation time provisioners on a high level, and then we'll move on to the next step of running the Terraform commands for provisioning or testing our file provisioner. Okay. So why we are putting this here is because during the creation of the resource, whatever the provisioners execute, so those are called creation time provisioners. Okay. So and during the destroy time of the resource, whatever the provisioners if you want to execute, those are called destroy time provisioners. So now for creation time provisioners are by default, there is no logic for them. If you define the provisioner, automatically it will be executed during the creation time. So that is very important thing. So by default, provisioners run when the resource they are defined within is created. What does this mean in a destroy time provisioner side? Okay, so if you go to our 0903 section local exec provisioner, in specific step 2, we will also implement the destroy time provisioner. Okay, at that point, if you want to implement or specifically say that this respective provisioner need to be executed during the destroy time, so you need to provide this, okay, tag when it is during destroy. Okay, so if this is not provided, then every provisioner whatever you are running will be provisioned during the creation time of the resource. So it will be triggered during the creation time of the resource. So that's about on a very high level about creation time provisioners. So they are meant as means to perform bootstrapping of a system, mainly for user data or cloud init scripts or packer scripts, whatever it is. Okay, if a creation time provisioner fails, the resource is marked as tainted. So another important point. So if my provisioner failed due to whatever the reason, immediately the resource whatever it is getting will get tainted. So you have learned in Terraform state about taint and then untaint. So if the resource is tainted, in the next Terraform apply, it is going to destroy and then recreate that resource. That's what the tainted means. So if a creation time provisioner fails, then it is going to mark as tainted, so that in the next Terraform apply, it is going to destroy that respective resource and then recreate it. A tainted resource will be planned for destruction and then recreation upon the next Terraform apply. So that is what is the definition of the tainting of a resource. And Terraform, why does this do is, Terraform does this because a failed provisioner can leave a resource in a semi-configured state if we don't do that. Okay, that's the reason Terraform will ensure that it will destroy and recreate in the next run of the Terraform apply by tainting the resource. So because Terraform cannot reason about what the provisioner does, the only way to ensure proper creation of a resource is to recreate it. So that's the reason it will do the tainting here. So you can change the behavior of the tainting by using the on failure attribute. So in our next step, means like after executing these commands and learning, so we will understand about failure behavior in detail. But on a very high level, you have a flag named on failure. So whenever you use this on failure, so you can continue without tainting the resource also, you can do that. Okay, so that's what it is telling us. So this is about on a high level about the creation time provisioners. We will go ahead and then execute the Terraform commands and then see what happens inside the /temp folder. Okay, so now let's go to our terminal and go to, we are in the 09 section, 09 provisioners and 0901 file provisioner, and inside that Terraform manifest section. So as usual, let's do the Terraform init and it will download the provider plugins. So if you see, we already came out of that remote backend stuff and everything. So that's the reason. So it is not initializing with any S3 bucket here. Okay, so we again came back to normal stuff of learning other concepts. Okay, so now if you see here, there is no remote provisioning, remote state storage and all those things. Our core focus in this example is about learning about the provisioners and file provisioner. Okay, so now it has initialized locally, and then backend is also, it is using the local backend and downloaded the plugins for AWS. Okay, or provider information it has downloaded. So if we want, we can run the Terraform validate once and then move on to the next steps here. Okay, format if you want, you can run. And now I'll say Terraform plan. So after that, we will do the Terraform plan auto approve and then log into that EC2 instance, and whether all the files copied as per the file provisioner or not, we are going to look into. So let's wait for the plan to be displayed. So plan is displayed for us here. So we can see. So it is going to create 2 security groups and 1 EC2 instance. Okay. So we will go down and we'll say Terraform apply auto approve, and this should create the EC2 instance. And once EC2 instance is created, we'll go ahead and then log in and verify the /temp folder. We can see it now. Our 3 resources got added. One is EC2 instance and then 2 security groups. Okay. Also, if you see, after creation complete, okay, so of VPC SSH, VPC web, both are created. These are security groups. Then EC2 VM got created here. Okay, so EC2 VM, after EC2 VM creation, during the process also it started provisioning with file once the EC2 VM is available for that using connection block. So you have 4 provisioners, okay, file provisioners you have defined in your C3 EC2 instance.tf, 1, 2, 3 and then 4, okay, provisioners. So 4 provisioners, provisioning the file provisioner, provisioning the file, and then provisioning the file. So everything is completed, and then it said creation complete and then so and so time. So now we will go inside and we'll say ssh-i, and then we have something called private keys folder, and inside that you have the terraform key.temp and ec2-user @ this one, okay, copy. So paste. So I can also copy this and then paste it in the documentation also for you. Okay, so let me go here. This is the readme and come here, and so connect command looks like this. Okay, so this one you can change with your respective IP address, right? Of your VM. Okay, so we'll log into EC2 instance and then test it. Verify, log into EC2 instance, verify whatever is present in. So we can say cd/temp and ls/lrta/temp to know what is present in temp folder. Good. So that's what it will get updated in the latest documentation in our steps here once I commit that code. Okay, so now let's go back here and then click on enter. So I'll say yes, and I'll go inside that respective VM. So it is saying that permission denied. Okay, so why? There might be a reason for your private key file has more access. Okay, so you need to say chmod 400 and private key and then terraform.key. So if this is there, then it will not do anything for us. So let me also update the same thing for you here. Okay, good. So now let's come here and then try the SSH one more time. Okay, so this should allow us to connect to the mission. You are in the mission EC2 user @ inside that mission. So now let's see cd/tmp. Okay, inside temp folder, if you see, you have the files, everything got copied. So let's see and then understand what it happened using this. Okay, so first thing is, with first file provisioner, you are going to copy whatever is present in apps/filecopy.html to temp filecopy.html. So you have that file copied to /temp. Okay, and second is, you have the file.log created in temp and then AMI information got present inside that file.log. So AMI used and then AMI name you have got here, which is 4892. Your AMI is 4892. So if you go here and then see the EC2 instance, so its AMI ID should be 4892, ended with 4892. See, that is the ID it has saved in file.log. And the third file provisioner you have implemented is, okay, copy the app1 entire folder to /temp. Okay, so if you see here, entire app1 folder is present and inside app1 you should have all other stuff, app1 file1 and then app2 file2. So let's come out of that and cd/temp and ls. And now the fourth thing is copy app2 folder contents to /temp. In app2 folder you have app2 folder 1, app2 file 1 and app2 file 2. So under temp all those things came in app2 file 1, app2 file 2 and then app2 folder 1. So all our file provisioners worked as expected without any issues. Means like we have tested everything and it worked as expected. So in our next lecture we are going to understand about decision making when provisioner fails and then implement that and then test it. So I'll see you in the next lecture. Until then, bye bye. Thank you.